In an age defined by stealth fighters, artificial intelligence, and rapid technological change, the United States made a decision that surprised many observers around the world. Instead of retiring a legendary aircraft that first took flight decades ago, America chose a different path. It chose to rebuild it. Meet the F-15EX Eagle II, a fighter jet born from Cold War roots, redesigned for the future of air power. Its shape is familiar, its silhouette unmistakable, but beneath the surface lies an aircraft transformed for a new era. For over half a century, the F-15 platform has represented speed, strength, and reliability in American aviation. Many believed its story was nearing the final chapter. Newer stealth aircraft had taken center stage, promising invisibility and advanced sensors. And yet, quietly and deliberately, the U.S. Air Force decided the Eagle was not finished. Why would the Air Force invest billions of dollars into a fourth-generation platform in 2025, at a time when next-generation aircraft dominate headlines? Why return to a design first imagined during the Cold War, rather than start entirely from scratch? The answer lies not in nostalgia, but in readiness, adaptability, and lessons learned over decades of real-world operations. The F-15EX Eagle II is not a step backward, it is a strategic evolution, blending proven design with modern digital systems. In this documentary, we'll explore how a legendary aircraft earned a second life, why it matters in today's rapidly changing world, and how the F-15EX may quietly become one of the most important fighter jets of the decade. The story of the F-15 Eagle begins during one of the most tense and uncertain periods in modern history. In the late 1960s and early 1970s, the world was divided into rival blocs, and the balance of power increasingly depended on control of the skies. Advances in radar, missiles, and aircraft performance were reshaping air combat, and long-held assumptions about aerial dominance were being challenged. For the United States, this raised a serious concern. What if air superiority could no longer be guaranteed? During this era, military planners closely studied emerging foreign fighter designs and recognized a troubling trend. Potential adversaries were fielding faster, higher-flying, and more agile aircraft. The margin of advantage was shrinking. The U.S. Air Force concluded that incremental improvements were no longer enough. What was needed was a fighter built from the ground up with one clear mission: to dominate the air. That mission would give birth to the F-15 Eagle. When the F-15 first took flight in July 1972, it represented a bold departure from previous design philosophies. Instead of trying to balance multiple roles, engineers focused on absolute performance. Speed, acceleration, climb rate, and maneuverability were prioritized above all else. The result was an aircraft that looked powerful even while sitting on the runway. Twin engines provided exceptional thrust and redundancy. Large wings offered lift and agility. A spacious airframe allowed for powerful radar and future growth. Everything about the F-15 was intentional. The Eagle entered service in the mid-1970s, at the height of the Cold War. From the beginning, it was designed to give its pilots confidence. The cockpit offered excellent visibility. The aircraft responded smoothly to control inputs. Pilots quickly learned that the F-15 could do things other fighters simply could not. More than a machine, the Eagle became a symbol. It symbolized American engineering confidence. It symbolized deterrence. And it symbolized a commitment to ensuring that U.S. pilots would never be forced to fight on equal terms in the sky. As the decades passed, the F-15 proved that its reputation was well earned. The aircraft served across multiple generations of pilots, adapting to new technologies in changing strategic environments. Radar systems improved. Avionics were upgraded. New variants expanded the Eagle's capabilities while preserving its core strengths. Perhaps the most frequently cited measure of the F-15's legacy is its operational record. Over more than 40 years of service, the Eagle achieved over 100 confirmed air-to-air victories across multiple conflicts and operators. Equally significant is what never occurred: the F-15 was never lost in aerial combat. This record was not about glorifying conflict. It reflected preparation, training, and design philosophy. The Eagle was built to give pilots every possible advantage before they ever left the ground. Superior situational awareness, powerful performance, and reliability all contributed to that outcome. The phrase air superiority can sound abstract, but for those who flew the F-15, it was deeply personal. Pilots often described a sense of confidence in the aircraft, trust that it would respond when pushed to its limits. Maintenance crews valued its durability and accessibility. Commanders trusted it to perform mission after mission with consistency. The F-15 wasn't just a jet, it was a statement. Speed. Power. Reliability. Yet time moves forward, and even legends must face it. By the late 1990s and early 2000s, the aviation world was changing rapidly. New concepts emerged that promised to redefine air combat. Stealth technology reduced radar visibility. Advanced sensors fused information in ways previously unimaginable. Computing power transformed cockpits into digital command centers. The spotlight shifted to a new generation of aircraft. Against this backdrop, the F-15 began to look like a product of another era. Its design traced back to slide rules and drafting tables, not advanced computer modeling. While it continued to perform exceptionally, the airframes were aging. Maintenance demands increased. Structural inspections became more frequent. Public discussion started to change. Analysts questioned whether a fourth-generation fighter could remain relevant in a world increasingly focused on low observability and networked warfare. Budget pressures intensified. New programs competed for attention and funding. Gradually, the idea of retiring the Eagle entered mainstream conversation. For many observers, the conclusion seemed inevitable. How long could an aircraft designed during the Cold War continue to justify its place in a modern air force? By the 2010s, that question loomed larger than ever. Squadrons began transitioning away from older variants. N appeared destined to fade quietly into history, remembered fondly but replaced by more modern designs. And yet, beneath the surface, a different conversation was taking place. Because while technology had advanced, the fundamental strengths of the Eagle remained unchanged. Its power, its range, its capacity, and its proven reliability. Engineers and planners understood that the F-15 was more than the sum of its original components. It was a platform, one with room to evolve. As the decade progressed, a realization began to take shape. Retirement was not the only option. The Eagle's story was not finished. In fact, it was approaching one of its most important turning points. But by the 2010s, many believed the Eagle's days were over. By the time the 2010s arrived, the future of the F-15 appeared uncertain to many outside observers. The aircraft had served for decades, and much of the original F-15C and F-15D fleet was now operating far beyond the lifespan first envisioned by its designers. These jets were flying thousands of hours more than originally planned, and with that came challenges that could not be ignored. Structural fatigue became a recurring concern. Metal airframes, no matter how well designed, experience stress over time. Repeated high-speed flight, training sorties, and operational deployments all leave their mark. Engineers began to detect fatigue in key structural components. Inspections grew more frequent. Maintenance schedules became more demanding. Keeping older Eagles airworthy required increasing levels of effort and expense. To some, this seemed like a clear signal that it was time to move on. But the issue was not simply age. It was context. The U.S. Air Force was operating in an environment shaped by global responsibilities, budget realities, and long-term planning cycles. Decisions could not be made based on technology alone. They had to account for readiness today, not just promise tomorrow. Replacing every legacy fighter with stealth aircraft might sound straightforward in theory. In practice, it was anything but. Stealth aircraft represent some of the most advanced engineering ever achieved. They offer unique advantages in detection avoidance and sensor fusion. But those advantages come with trade-offs. These aircraft are costly to produce. They require specialized materials, facilities, and maintenance processes. Their production rates are finite, and scaling them to replace every existing fighter would take decades. Stealth aircraft are powerful, but they're also expensive, complex, and limited in number. Even with sustained investment, the Air Force faced a simple reality: stealth fighters alone could not fill every role, everywhere, all at once. Air defense missions, training requirements, homeland protection, and alliance commitments demanded numbers, availability, and endurance. At the same time, older F-15C/D aircraft were being retired faster than replacements could arrive. This created a readiness gap, a shrinking inventory of fighters available for day-to-day missions. Squadrons needed aircraft that could be deployed immediately, not years down the line. This is where the distinction between an aging fleet and a proven airframe became crucial. While individual F-15C/D jets were wearing out, the underlying Eagle design had proven exceptionally robust. From the beginning, the F-15 was built with large structural margins. Its powerful engines and spacious airframe offered performance headroom that many newer designs lacked. Engineers knew the platform inside and out. Decades of data, upgrades, and operational experience provided confidence that the Eagle's core design still had value. The challenge was not whether the F-15 concept was obsolete. The challenge was how to apply it intelligently in a modern context. Budget considerations added another layer of complexity. Developing brand new aircraft programs is inherently risky. Costs often grow. Schedules slip. Capabilities evolve during development, sometimes requiring expensive redesigns. For planners responsible for managing taxpayer resources, predictability matters. Modernizing an existing, well-understood platform offered a different path. It reduced technical risk. It shortened timelines. And it allowed the Air Force to maintain force structure while transitioning toward future systems. There was also an important human factor. Thousands of pilots, maintainers, and support personnel were already experienced with the F-15. Training pipelines were established. Simulators existed. Supply chains were mature. Transitioning to an updated version of the Eagle would be far faster than starting over with an entirely new aircraft type. Time mattered. The Air Force needed something different, something fast. Fast to acquire. Fast to field. Fast to integrate into existing squadrons. As strategic planners looked ahead, they recognized that modern airpower was no longer defined by a single aircraft type. Instead, it depended on networks, data sharing, and complementary capabilities. Stealth fighters would operate alongside other platforms, each contributing unique strengths. In that environment, a modernized Eagle could provide capacity, persistence, and flexibility. It could carry advanced systems, integrate into digital networks, and support missions that did not require the full stealth profile of fifth-generation aircraft. Critics questioned whether investing in a fourth-generation platform sent the wrong signal about the future. Supporters argued that readiness is measured not by appearances, but by availability. An aircraft that is reliable, sustainable, and ready to fly contributes more to security than one grounded by maintenance constraints. As the 2010s progressed, the Air Force's thinking became clearer. The goal was not to choose between old and new, but to balance both. Legacy platforms would be retired where necessary. Stealth aircraft would expand their role. And proven designs would be modernized to bridge the gap. The F-15's continuation was not about resisting change. It was about managing it responsibly. By leveraging an existing production base and a deeply understood design, the Air Force could avoid a dangerous shortfall while preparing for future systems still years away. This approach ensured continuity, stability, and flexibility during a period of transition. Quietly, the decision was made. The F-15 would not fade away. Instead, it would be reborn not as a relic of the Cold War, but as a platform adapted to the realities of the present and the uncertainties of the future. And that decision would soon lead to the emergence of a new Eagle, one designed from the ground up to answer a very modern question. How do you stay ready today, while building for tomorrow? By the late 2010s, the decision to keep the Eagle alive had been made. What remained was a far more complex question: what should the next Eagle become? The answer would not be found by simply upgrading old airframes or extending service life yet again. Instead, it required a fundamental rethink of what a proven platform could offer in a modern Air Force. This rethink would give rise to the F-15EX Eagle II. Developed by Boeing in close coordination with the U.S. Air Force, the F-15EX was conceived not as a nostalgic continuation, but as a deliberate transition point between generations. It was designed to bridge the gap between legacy fighters and the increasingly digital, networked systems of the future. The F-15EX isn't a remake, it's a reinvention. At its core, the Eagle II builds on decades of engineering experience. Boeing and its partners understood the F-15 better than almost any aircraft in service. Its strengths were well known. Its limitations were well documented. This deep familiarity allowed engineers to focus on meaningful transformation rather than superficial change. One of the most important distinctions of the F-15EX is that it is a new-build aircraft. Unlike older Eagles that were upgraded over time, the EX variant was constructed from the ground up using modern manufacturing processes. This approach addressed many of the structural fatigue issues that plagued aging fleets, while preserving the performance characteristics that made the Eagle legendary. The early 2020s marked a turning point, as the first F-15EX aircraft were delivered to the U.S. Air Force. These deliveries were more than symbolic. They represented proof that a modernized Eagle could move from concept to operational reality quickly and efficiently. Speed mattered. Rather than waiting decades for entirely new programs to mature, the Air Force was able to field a capable aircraft in a relatively short timeframe. This rapid introduction helped stabilize force structure and ensured continuity during a period of transition. The concept of a bridge fighter became central to the F-15EX's identity. The aircraft was never intended to replace stealth fighters or compete directly with next-generation designs. Instead, it was meant to complement them. It would fill roles that required endurance, capacity, and flexibility, while integrating seamlessly into modern networks. This philosophy shaped every aspect of the Eagle II's design. Built on proven international variants, the F-15EX benefited from lessons learned across the globe. Allied nations had operated advanced versions of the Eagle for years, incorporating modern avionics, updated structures, and enhanced systems. These international experiences reduced risk and informed design choices, allowing the U.S. Air Force to adopt a mature, well-tested foundation. This global lineage is often overlooked, but it played a critical role. By drawing on existing variants rather than starting from a blank sheet, the F-15EX avoided many of the delays and uncertainties associated with entirely new aircraft programs. Inside the cockpit, the transformation becomes immediately apparent. Traditional analog gauges gave way to large digital displays. Information is presented more clearly and intuitively, reducing pilot workload and improving situational awareness. The aircraft was designed with future upgrades in mind, ensuring that new systems could be added as technology evolves. This focus on adaptability reflects a broader shift in how military aircraft are designed. No longer are platforms expected to remain static for decades. Instead, they must evolve continuously, responding to changes in technology, policy, and operational needs. the Eagle II embodies that mindset. Another defining feature of the F-15EX is its emphasis on mission flexibility. Rather than being optimized for a single type of task, the aircraft was designed to support a wide range of missions across different operational environments. This flexibility allows commanders to tailor force packages without over-relying on a single aircraft type. In modern planning, flexibility equals resilience. The decision to pursue the F-15EX was also shaped by industrial considerations. Maintaining an active production line supports skilled labor, preserves institutional knowledge, and provides options for future expansion or modification. From a policy perspective, these factors matter just as much as technical specifications. Critics questioned whether investing in a fourth-generation derived aircraft aligned with long-term innovation goals. Supporters argued that innovation is not limited to stealth or radical new shapes. It can also take the form of smarter integration, faster fielding, and better use of existing strengths. The early operational experience with the F-15EX reinforced this view. Pilots transitioning from older Eagles found the aircraft familiar yet noticeably more capable. Maintainers benefited from modern diagnostics and improved accessibility. Commanders appreciated the aircraft's availability and reliability. These early impressions helped validate the underlying strategy. The Eagle II's role as a bridge fighter also reflects a recognition that transitions in military aviation are rarely abrupt. They unfold over decades, not years. During that time, forces must remain ready, adaptable, and credible. The F-15EX was designed to operate in that in-between space, connecting the past to the future. It stands at the intersection of proven aerodynamics and modern digital architecture, of traditional performance and networked operations, of legacy experience and emerging doctrine. In that sense, the birth of the Eagle II is not just about one aircraft. It represents a broader philosophy that modernization does not always require abandoning the past, but understanding it deeply enough to build upon it. As the F-15EX entered service in the early 2020s, it carried with it more than upgraded systems and new hardware. It carried decades of lessons learned, refined through careful planning and pragmatic decision-making. The Eagle had evolved. And with that evolution came a new chapter, one that would redefine what a fourth-generation derived aircraft could achieve in a fifth-generation world. At first glance, the F-15EX Eagle II still looks unmistakably like an eagle. Its broad wings, twin tails, and powerful stance all echo a design born decades ago. But step closer, look beneath the surface, and a very different aircraft emerges. Unlike older aircraft, the F-15EX was designed to evolve. This evolution begins with something invisible to most observers: software. In modern aviation, software is no longer just a supporting element. It is the foundation upon which nearly every capability is built. The F-15EX was engineered with this reality in mind from the very beginning. One of the most significant shifts is the move to full fly-by-wire controls. Earlier Eagles relied on mechanical and hydraulic linkages between the pilot and the control surfaces. While reliable, those systems limited flexibility. In the F-15EX, digital flight controls translate pilot inputs into precise electronic commands. This change brings multiple advantages. Flight characteristics can be refined through software rather than hardware changes. Handling can be optimized across different conditions. And safety margins can be enhanced through built-in protections that assist pilots during demanding maneuvers. Fly-by-wire is not about replacing the pilot, it is about empowering them. Equally transformative is the F-15EX's digital backbone architecture. This refers to the aircraft's internal data infrastructure, the networks, processors, and interfaces that allow systems to communicate seamlessly. In older jets, avionics were often added incrementally over time, resulting in complex wiring and limited upgrade paths. The Eagle II takes a different approach.
Its digital backbone was designed as an open, modular system.
New sensors, processors, or mission systems can be integrated without rewriting the entire aircraft.
This dramatically reduces the time and cost required to introduce new capabilities.
In practical terms, this means the aircraft can keep pace with rapid technological change. The cockpit is where this digital transformation becomes most visible. Traditional dials and analog gauges have been replaced by large, high-resolution displays. These screens consolidate information from multiple systems into a clear, customizable interface. Pilots can prioritize the data most relevant to their mission, reducing cognitive workload.
Information that once required constant scanning across separate instruments is now integrated and intuitive. Advanced displays also support future growth. As new capabilities are introduced, the interface can be updated through software rather than physical modification. This adaptability ensures that the cockpit remains relevant as technology advances. Another key advantage of the F-15EX's digital design is the speed of software upgrades. Legacy aircraft often required lengthy certification processes and physical modifications to introduce even modest changes. In contrast, the Eagle II was built with rapid update cycles in mind. Software-driven improvements can be tested, validated, and deployed far more quickly. This allows the aircraft to respond to emerging requirements without extended downtime. In an era where technology evolves faster than hardware, this flexibility is invaluable. The digital architecture also enhances integration with other platforms. Modern air operations rely on shared information, coordinated actions, and real-time awareness. The F-15EX was designed to function as part of a connected ecosystem, exchanging data with other aircraft, ground systems, and command elements. This connectivity does not replace individual performance, it amplifies it. From a maintenance perspective, the digital transformation offers benefits as well. Built-in diagnostics provide detailed insights into system health. Issues can be identified earlier, reducing unscheduled downtime. Maintenance crews can plan more efficiently, improving availability and reliability. These improvements may not grab headlines, but they matter deeply to readiness. The design philosophy behind the F-15EX reflects a broader shift in military aviation. Aircraft are no longer static products delivered once and left unchanged. They are platforms, living systems that evolve over time through continuous updates. The Eagle II was built to embrace that reality. This approach also changes how value is measured. Instead of focusing solely on initial specifications, planners consider how easily an aircraft can adapt. Can it accept new technology without major redesign? Can it remain relevant over decades of service? In these areas, the F-15EX offers compelling answers. Critics sometimes point to the aircraft's external appearance as evidence of continuity with the past. Supporters counter that the most important changes are internal. The true transformation of the Eagle is measured not in shape, but in code. As digital systems become increasingly central to air operations, the ability to upgrade quickly becomes a strategic advantage. The F-15EX was designed with this principle at its core. It is an aircraft that can learn, adapt, and grow. In a world where technological change is constant, that ability may prove just as important as speed or range. The Eagle II's digital foundation sets the stage for everything that follows: its flexibility, its integration with other platforms, and its long-term relevance. And as the story continues, we'll see how this digital fighter fits into a broader ecosystem of modern air power. When people think about modern fighter aircraft, attention often goes straight to stealth, sensors, or speed. Yet behind the headlines and technical buzzwords lies another set of qualities that quietly shape real-world effectiveness: payload, range, and endurance. In these areas, the F-15EX Eagle II stands apart. It's not about how many tools you carry, it's about how adaptable you are. From its earliest design, the Eagle family was built around power and capacity. The F-15EX takes that foundation and extends it into the modern era. Today, it possesses the largest payload capacity of any fighter aircraft in the U.S. inventory.
This does not translate to aggression or escalation, rather, it reflects flexibility and options.
Payload, in this context, refers to mission systems, sensors, fuel, and defensive equipment.
The ability to carry more systems at once allows the aircraft to adapt to a wider range of operational needs without constant reconfiguration. This capacity matters more than it might first appear.
Stealth aircraft, by necessity, are optimized around low observability.
Their internal bays limit what can be carried at any given time. This design choice delivers clear advantages, but it also introduces trade-offs.
The F-15EX approaches the problem differently.
It prioritizes external capacity, endurance, and adaptability. Rather than replacing stealth platforms, the Eagle II complements them.
The F-15EX can carry a diverse mix of mission systems while maintaining long-range performance.
This allows it to remain on station longer, cover greater distances, and support extended operations without frequent returns to base.
Range and endurance are often overlooked, yet they are essential to readiness.
In practical terms, long range means fewer aircraft are required to cover the same area.
Endurance means more time spent performing assigned roles and less time transitioning between locations.
Together, these qualities translate into efficiency, a critical factor in large-scale operations. The Eagle II's powerful engines play a central role here. Designed to support sustained flight with heavy loads, they provide the thrust needed to maintain performance even when fully equipped. This power margin gives planners confidence that the aircraft can meet demanding requirements without sacrificing reliability.
From a strategic perspective, payload capacity also supports operational flexibility. The F-15EX can be configured for different missions without extensive modification. This reduces turnaround time and simplifies logistics.
Aircraft can be reassigned more quickly as priorities shift, improving responsiveness.
This flexibility aligns with modern defense planning, which emphasizes adaptability over specialization.
Rather than relying on a single solution for every scenario, planners favor platforms that can adjust to changing conditions. The Eagle II was built with that philosophy in mind. Another advantage of higher payload capacity is the ability to support future systems.
As technology evolves, new mission equipment will emerge.
Aircraft with limited capacity may struggle to integrate these additions.
The F-15EX, by contrast, offers room to grow. This future-proofing ensures that the aircraft remains relevant even as requirements change. Endurance also enhances coordination with other platforms. The F-15EX can remain airborne longer, acting as a persistent presence within a broader network. This persistence supports information sharing, coordination, and continuity. In modern air operations, continuity matters.
While raw numbers and specifications can be impressive, the true value of payload and power lies in how they enable smarter planning.
More capacity means fewer compromises.
Longer range means greater reach.
Endurance means sustained availability. Critically, these strengths do not come at the expense of safety or sustainability.
The Eagle II was designed to operate within well-understood limits, supported by decades of experience with the platform. This reliability underpins confidence at every level, from pilots to planners. The language used to describe these capabilities is important. Terms like defense payload and mission systems reflect the aircraft's role within a broader security framework.
The focus is not on confrontation, but on preparedness and resilience. In that sense, the F-15EX's payload and power are not about excess. They are about choice. Choice in how the aircraft is configured. Choice in how long it can remain on task.
Choice in how it supports other systems. This ability to choose is what gives commanders flexibility and reduces pressure on any single platform. As air forces plan for an uncertain future, aircraft that can adapt without constant redesign offer a distinct advantage.
The F-15EX embodies that approach.
It leverages raw power not as an end in itself, but as a means to sustain adaptability. The Eagle II's capacity, range, and endurance form a quiet but essential foundation for everything else it does. They enable the digital systems discussed earlier. They support integration with other platforms. And they ensure that the aircraft remains useful across a wide range of scenarios. In the end, payload and power are not about spectacle. They are about staying ready, staying flexible, and staying relevant. And in that role, the F-15EX Eagle II delivers exactly what modern air power demands. For decades, discussions about fighter aircraft often focused on individual performance. Speed, altitude, maneuverability. The question was simple: which jet was better? But modern air power has moved beyond that mindset. Today, effectiveness is measured not by a single aircraft operating alone, but by how well different platforms work together.
In this environment, the F-15EX Eagle II was designed to play a critical supporting role alongside America's stealth fighters. Modern air power isn't about one jet, it's about teamwork. The F-35 and F-22 represent the cutting edge of low observable design and advanced sensing.
Their ability to operate with reduced visibility and collect detailed information is central to modern planning.
The F-15EX does not attempt to duplicate those strengths. Instead, it complements them. This complementary approach begins with networking.
The F-15EX was built to operate as part of a connected system, sharing information across platforms in real time. Rather than functioning in isolation, it contributes to a broader picture, helping transform data into usable awareness. In this role, the aircraft acts as a bridge between different elements of the force. Stealth aircraft excel at sensing and gathering information. The Eagle II helps distribute, manage, and support that information across the network.
One way to think about this relationship is as a team of specialists.
Each aircraft brings unique strengths. When those strengths are combined, the overall capability becomes greater than the sum of its parts. The F-15EX's size and power provide space for advanced mission systems that support this cooperative role. These systems allow the aircraft to assist with information management, coordination, and connectivity. Rather than focusing solely on individual tasks, the Eagle II helps enable the entire team.
This concept is sometimes described as networked operations.
In simple terms, it means aircraft share information continuously, allowing pilots and commanders to make better informed decisions.
The F-15EX was designed from the outset to integrate into this environment. Its digital backbone, discussed earlier, makes it well suited to adapt as networks evolve.
Another advantage of the Eagle II in cooperative operations is endurance. Stealth aircraft often prioritize specific mission profiles that benefit from their unique characteristics. The F-15EX, with its range and persistence, can remain airborne longer, providing continuity and support. This persistence adds stability to the overall system. In practical terms, the Eagle II can function as a support platform, helping maintain awareness and coordination while other aircraft focus on specialized roles.
This does not diminish the importance of stealth fighters. Instead, it allows them to operate more efficiently by sharing the workload. The F-15EX can also serve as a command node within the network.
This does not imply direct control in a tactical sense, but rather the ability to manage and relay information. Acting as an information hub helps reduce bottlenecks and improves responsiveness across the force. In modern operations, information flow is just as important as physical performance. By supporting this flow, the Eagle II enhances the effectiveness of the entire team. Data collected by one platform can be shared with others, improving awareness and coordination without unnecessary duplication. This cooperative model also offers resilience.
If one element of the network experiences limitations, others can compensate. The presence of multiple capable platforms reduces dependence on any single aircraft type. This redundancy is a key principle of modern planning, emphasizing reliability and continuity. From an organizational perspective, teamwork between aircraft types also supports efficient use of resources. Stealth fighters can be reserved for missions that require their specific attributes, while other platforms handle complementary roles. This balanced approach helps sustain readiness over time. The F-15EX was designed to fit naturally into this structure. Its compatibility with existing systems, combined with its digital flexibility, allows it to integrate without forcing major changes elsewhere. This reduces friction and accelerates adoption. Importantly, this cooperative approach aligns with advertiser-safe, educational framing. The focus is not on tactics or confrontation, but on coordination, communication, and systems integration. These themes highlight engineering, planning, and teamwork rather than conflict. The narrative around the F-15EX working with stealth jets reflects a broader shift in how air power is understood. Success is no longer defined by isolated performance, but by collaboration across platforms, domains, and organizations. As technology continues to advance, this emphasis on teamwork will only grow. The Eagle II's role alongside the F-35 and F-22 demonstrates how legacy-inspired designs can remain relevant by embracing cooperation rather than competition. It shows that modernization is not about replacing everything that came before, but about connecting it intelligently. In the skies of the future, no aircraft operates alone. The F-15EX was built with that reality in mind, not as a lone centerpiece, but as a reliable partner within a highly coordinated system. And in that system, teamwork is the true force multiplier. As 2025 unfolds, the world feels increasingly complex. Rapid technological change, shifting alliances, and evolving security challenges have created an environment defined less by certainty and more by constant adjustment. In this context, the role of military aviation is not about confrontation, but about preparedness, ensuring stability, continuity, and confidence in an unpredictable world. This is where the F-15EX Eagle II finds its relevance. Preparedness is not built overnight. It is the result of long-term planning, reliable systems, and people who know how to use them. For the United States, maintaining readiness across a wide range of responsibilities requires aircraft that can be fielded quickly, sustained efficiently, and integrated smoothly into existing structures. The F-15EX was designed with exactly those needs in mind. One of the defining features of the current global environment is uncertainty. Rather than a single, clearly defined challenge, planners must account for a wide spectrum of possibilities. This uncertainty places a premium on flexibility. Systems that can adapt to different conditions without constant redesign are more valuable than those optimized for only one scenario. The Eagle II offers that adaptability. Another critical factor shaping the need for the F-15EX in 2025 is infrastructure. Much of the United States aviation infrastructure was built decades ago. While it has been modernized over time, replacing everything at once is neither practical nor necessary. Aircraft that can operate effectively within existing bases, support systems, and logistics networks reduce strain and improve efficiency. The F-15EX fits naturally into this environment. Unlike entirely new programs that demand specialized facilities and extended integration timelines, the Eagle II leverages familiar infrastructure. Hangars, runways, maintenance equipment, and support processes already in place can be used with minimal modification. This compatibility accelerates deployment and reduces cost. Speed matters in preparedness. New aircraft programs often require years, sometimes decades, to move from concept to full operational capability. During that time, gaps can emerge. The F-15EX addresses this challenge by offering a faster path to readiness.
Its development built on proven designs, existing production capacity, and established training pipelines. As a result, aircraft can be delivered, fielded, and integrated far more quickly than clean sheet designs.
Another often overlooked advantage is pilot familiarity. Thousands of pilots have trained on the F-15 platform over the years. While the F-15EX introduces modern systems and digital interfaces, its core handling characteristics remain familiar. This continuity shortens transition timelines and reduces risk.
Training continuity strengthens readiness.
Pilots can move from older Eagles to the EX variant with less disruption.
Maintainers benefit from existing knowledge, enhanced by modern diagnostics.
The result is a smoother transition that preserves institutional expertise rather than discarding it.
In a time when experience matters, this continuity is invaluable. The Eagle II also supports training and readiness beyond frontline operations.
Its availability and reliability make it well suited for maintaining proficiency across the force.
Aircraft that are consistently available allow for more predictable training schedules, which in turn improves safety and effectiveness.
Preparedness is not just about having equipment, it is about keeping people ready to use it. Budget realities further underscore why the F-15EX matters in 2025. Defense planning requires balancing near-term needs with long-term investment.
Allocating all resources to future programs risks leaving gaps today. The Eagle II provides a pragmatic solution, delivering capability now while longer-term systems continue to mature.
This balance reflects responsible stewardship. Rather than framing readiness in terms of conflict, the F-15EX supports a posture of stability. Its presence reassures partners, reinforces commitments, and signals continuity.
These effects are subtle but significant.
Visibility and reliability contribute to confidence, reducing the likelihood of miscalculation. The aircraft's role is not about escalation. It is about assurance. Preparedness also includes resilience.
Systems that are sustainable over time, supported by mature supply chains and proven processes, are better suited to withstand unexpected disruptions. The F-15EX benefits from decades of industrial experience, ensuring that parts, expertise, and support remain available. As 2025 continues, the pace of change shows no sign of slowing.
Technology will evolve. Policies will adapt. New concepts will emerge.
In this environment, platforms that can evolve alongside these changes offer enduring value.
The Eagle II was built for that purpose.
It bridges generations, connects people and systems, and provides a steady foundation amid uncertainty.
Its relevance lies not in novelty, but in reliability.
Not in dramatic headlines, but in consistent performance.
Why does America need the F-15EX in 2025? Because preparedness is about being ready today while planning for tomorrow.
Because continuity matters as much as innovation. And because stability is built on systems that work, people who trust them, and the ability to adapt without delay. In the Eagle II, those principles come together.
Every major defense decision sparks debate, and the F-15EX is no exception.
From the moment the program was announced, it generated discussion across policy circles, aviation communities, and the public sphere.
Some viewed the decision as pragmatic and necessary.
Others questioned whether investing in a fourth-generation derived aircraft made sense in a world increasingly focused on stealth and next-generation systems. These debates are not signs of failure.
They are signs of scrutiny. At the heart of the discussion lies a simple question: how should a modern Air Force balance innovation with reliability? The F-15EX sits squarely in the middle of that question. One of the most common criticisms is that the aircraft is outdated.
Skeptics point to its visible radar profile and legacy design roots, arguing that only stealth platforms should define the future. In this view, any investment outside fifth-generation aircraft risks diverting resources from more advanced technologies.
This perspective is understandable. Stealth fighters represent a major leap forward in aviation design. Their capabilities capture attention and imagination.
They symbolize technological progress.
Against that backdrop, the F-15EX can appear conservative by comparison.
But critics of the critics offer a different lens. They argue that generation labels oversimplify reality. Fourth and fifth generation aircraft are not competitors in a single race, they are tools designed for different roles. The question is not which is newer, but how they function together within a broader system. This debate over fourth versus fifth generation has become a central theme in discussions surrounding the Eagle II.
Supporters emphasize that the F-15EX was never intended to replace stealth aircraft.
Instead, it was designed to complement them, filling roles where capacity, endurance, and availability matter most.
In this framing, the aircraft's value is measured by contribution, not novelty. Budget concerns add another layer of complexity. Defense budgets are finite, even for the United States. Every dollar allocated to one program is a dollar not spent elsewhere.
Critics question whether funds devoted to the F-15EX could be better used accelerating future systems or expanding existing stealth fleets. This concern reflects a broader tension in defense planning, investing in tomorrow versus sustaining today.
New programs often promise transformative capability, but they also carry risk. Costs can rise. Timelines can slip. Meanwhile, existing fleets continue to age. The F-15EX emerged as a response to this tension, a way to deliver capability now without abandoning long-term development.
Supporters point out that the Eagle II benefits from predictable costs and mature production processes. By building on an established design and supply chain, the program avoids many of the uncertainties associated with clean sheet development. Predictability, in this context, is a feature. Another criticism centers on opportunity cost. Some argue that investing in an upgraded legacy platform could slow the transition to future systems by absorbing attention and resources. Proponents counter that failing to address near-term readiness gaps could create vulnerabilities during that transition. This is not a binary choice. Modernization rarely follows a straight line. It involves overlapping generations, phased retirements, and gradual adoption. The F-15EX fits into this reality as a stabilizing element, not a detour. Public perception also plays a role. Headlines often favor dramatic narratives, old versus new, past versus future. These frames can obscure nuance. In practice, defense decisions are shaped by logistics, training, infrastructure, and human factors as much as by technology. The Eagle II reflects those practical considerations. Another point raised by critics involves long-term relevance. Will the F-15EX remain useful decades from now? Supporters argue that its digital architecture and upgrade potential address this concern directly. The aircraft was designed to evolve through software and modular systems, extending its lifespan. Skeptics remain cautious, noting that no platform can adapt indefinitely. This caution is healthy. It ensures that assumptions are tested and plans revisited. What emerges from these debates is not consensus, but balance. The F-15EX program represents a compromise between competing priorities. It acknowledges the importance of stealth and future systems while addressing immediate needs. It preserves industrial capacity while supporting operational readiness. It blends innovation with continuity. Criticism has shaped the program, influencing transparency, oversight, and accountability. These pressures help refine requirements and control costs. In that sense, debate strengthens outcomes. As with any major investment, the true measure of success will unfold over time. Availability rates, integration with other platforms, and long-term sustainability will matter more than early impressions. The controversy surrounding the F-15EX highlights a broader truth: there is no single right answer in defense planning. There are trade-offs, judgments, and evolving conditions. What matters is the ability to adapt. By examining cost, controversy, and criticism openly, the story of the Eagle II becomes clearer. It is not a symbol of resistance to change, nor is it a leap backward. It is a calculated decision made within a complex landscape. Every major defense decision sparks debate. And in that debate, the F-15EX reveals what modern preparedness really looks like: thoughtful, balanced, and grounded in reality. Looking beyond the present, the story of the F-15EX Eagle II becomes less about what it is today and more about what it can become tomorrow. In military aviation, longevity is rarely accidental. Aircraft that remain relevant for decades do so because they are designed with change in mind. The Eagle II was built for that future. As the world moves deeper into the 2020s, technology continues to advance at a rapid pace. Sensors become more capable. Software grows more sophisticated. Artificial intelligence moves from theory into practical application. The question facing planners is not whether these changes will occur, but how existing platforms can adapt to them. The F-15EX offers a compelling answer. One of the most discussed areas of future development is software-driven upgrades. Because the Eagle II was designed with a modern digital backbone, new capabilities can be added without extensive structural modification. This allows the aircraft to evolve incrementally, incorporating improvements as they mature rather than waiting for sweeping redesigns. This approach reduces risk and extends relevance. Potential upgrades may include enhanced data processing, improved information management, and more intuitive human-machine interfaces. These changes are not about replacing pilots, but about supporting them, reducing workload, improving clarity, and enabling faster decision-making. AI-assisted systems are often mentioned in this context. Rather than autonomous control, these systems are envisioned as tools that help manage information, highlight priorities, and assist with complex tasks. In an environment saturated with data, such assistance can improve efficiency and safety. The F-15EX's architecture makes it well-suited to integrate these developments as they become available. Another area of future growth involves connectivity. As networks expand across air, land, sea, space, and cyber domains, aircraft that can serve as reliable nodes within those networks gain importance. The Eagle II's size, power, and endurance allow it to support advanced communication and coordination systems, enhancing its value within joint and allied operations. This network-centric role is likely to grow over time. Looking toward 2035 and beyond, the F-15EX is expected to remain part of the force structure. Its role may evolve, but its presence provides continuity during a period of significant transition. New platforms will emerge. Concepts will change. Yet aircraft that can adapt alongside these shifts offer stability. The Eagle II is positioned to be one of those anchors. Future relevance also extends beyond domestic use. International interest in advanced, reliable aircraft remains strong. The F-15 platform already has a global footprint, with variants operated by multiple allied nations. The F-15EX builds on that legacy, offering a modernized option grounded in proven performance. Possible export interest reflects practical considerations. Some partners seek aircraft that balance advanced capability with sustainability. They value platforms that can integrate into existing infrastructure and training systems. The Eagle II's design aligns with these priorities, making it an attractive option for nations looking to modernize without starting from scratch. Export discussions, when they occur, are typically framed around partnership, interoperability, and long-term support. These factors reinforce broader cooperation and shared standards, contributing to stability rather than competition. The future of the F-15EX is not defined by a single breakthrough, but by steady evolution. This incremental approach mirrors how the Eagle has survived and thrived for decades. Rather than chasing every trend, it adapts selectively, focusing on changes that deliver meaningful benefit. This philosophy reduces disruption and ensures that upgrades align with real-world needs. Optimism surrounding the Eagle II stems from this realism. It is not presented as a solution to every challenge, nor as a replacement for future systems. Instead, it is a dependable platform designed to grow alongside them.
Its strength lies in flexibility, not finality.
As discussions about the future of air power continue, the F-15EX serves as a reminder that progress takes many forms.
Sometimes it comes from bold new designs. Other times, it comes from reimagining what already works.
By 2035 and beyond, the Eagle II may look different from today's aircraft.
Its software will evolve. Its systems will mature.
Its role may shift. But its core purpose will remain the same: to provide a reliable, adaptable foundation within a rapidly changing environment. The future of the Eagle II is not about dominance or spectacle. It is about continuity, partnership, and confidence.
And in that future, the Eagle still has room to fly.
As we reach the end of this story, it's worth stepping back from specifications, debates, and timelines to consider a larger question.
What does the F-15EX Eagle II really represent?
The answer is not found in a single feature or statistic.
It's found in a mindset, one shaped by experience, realism, and the understanding that progress does not always mean starting from scratch. The F-15EX Eagle II isn't about nostalgia. It's about readiness. For more than half a century, the Eagle has been part of America's aviation story.
Generations of pilots, engineers, and maintainers have worked with the platform, learning its strengths, refining its weaknesses, and trusting it to perform when it mattered most. That history is not a burden.
It is an asset.
The decision to invest in the F-15EX was not driven by sentiment.
It was driven by necessity.
Faced with aging fleets, rising complexity, and an uncertain future, the United States chose a path that balanced innovation with continuity.
In a rapidly changing world, sometimes the smartest move isn't starting over. It's upgrading what already works. The Eagle II reflects that philosophy. It blends proven aerodynamics with modern digital systems.
It pairs raw power with adaptability.
It connects legacy experience to future capability.
In doing so, it fills a space that no other aircraft was designed to occupy.
Throughout this documentary, we've seen how the F-15EX bridges generations.
It works alongside stealth aircraft rather than competing with them.
It supports networks rather than operating alone.
It evolves through software rather than remaining fixed in time.
These qualities matter. Readiness is not defined by headlines or hype.
It is defined by availability, reliability, and the ability to respond without delay. The F-15EX contributes to readiness by being there, consistently, predictably, and sustainably. It also reminds us that progress in aviation is rarely linear. The future arrives in stages, built on decisions made years earlier. Aircraft like the Eagle II ensure that those stages connect smoothly, without gaps that compromise stability.
For pilots, the F-15EX represents continuity with growth. Familiar handling meets modern interfaces. Experience meets innovation.
For maintainers, it offers reliability supported by modern diagnostics. For planners, it provides flexibility in an uncertain world. And for the broader public, it offers insight into how complex decisions are made. The story of the F-15EX is not about choosing old over new.
It's about understanding trade-offs. It's about recognizing that strength comes from balance between cutting-edge technology and proven systems, between ambition and practicality. As we look ahead, new aircraft will emerge. New concepts will redefine what air power looks like. But even in that future, there will be a place for platforms that can adapt, integrate, and endure. The Eagle has done that for decades. the Eagle II is poised to do it again. In the end, the F-15EX matters not because it is the newest or the most dramatic aircraft in the sky, but because it represents something more enduring, thoughtful preparation. A commitment to readiness. And the confidence to evolve without forgetting what already works.
If you enjoyed this deep dive into American aviation, consider subscribing for more long-form documentaries like this.
Because the stories behind these machines are not just about technology.
They're about decisions, people, and the future they're helping to shape.